Okay. Today, I will talk about section 11.3, the integral test and estimating of sums. This is outline. The first, I will talk about what is the integral test. Second one, what is the P series? So I will give some examples. So in general, it is difficult to find the exact sum of a series. Therefore, in the next few sections, we develop several tests that enable us to determine whether a series is convergent or divergent without explicitly finding its sum. We begin by investigating the following two series. Summation from n equal to 1 to infinity, 1 over n squared, like 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared, and so on. One more example is summation n equal to 1 to infinity, 1 over square root of n. So 1 over the square root of 1 plus 1 over square root of 2 plus 1 over square root of 3 plus, and so on. So I'm going to check these two series are convergent or divergent. I'm going to check these kind of things. So here, the first example. So how can you solve this kind of problem? So I'm going to use this idea. So we can draw graph. You can replace 1 over n squared by the function 1 over x squared. You can replace the f of x is like 1 over x squared. But next, you can sketch the graph. You can sketch the graph like this. So here, this one. You can draw 1 over x squared. Graph is like this. This one. This is 1 over x squared. So next, so we choose a point here. I can choose here, point 1. You can define function value here. What is like a function value? You plug 1 into x squared, so we have 1 over 1 squared. You can choose 2. Here, plug 2 into 1 over x squared. So what is this y value? So what's that? So could you write your answer? So what is the y value? So this is like 2. What is the y value? 0.5? I don't think so. Yeah, 1 over 4. You can plug 2 into x. 2 into x. We have 1 over 2 squared. So like this. You choose 3. Same. You plug into function exactly 1 over 3 squared. You choose 4. Plug into function here 1 over 4 squared. You choose 5. So we have 1 over 5 squared. So like this. So this is like idea. The next is So I want to make rectangle here. You can choose this point. You can make rectangle is like this. Rectangle. So find this area. You can make another rectangle here. This one. You can find this area. Similarly, this rectangle, find area. This rectangle and find area. So like this. So first one, what's the area of this one? So what's the area of the first rectangle? This one. What's the area of first rectangle? This one. The 1/4. You're right. So here, the width is 1. The length is exactly 1/2 square. So this is 1 times 1/2 square is 1/2 square. So like this. Here, what is one? What is rectangle? What's the area of this rectangle? This one. Yep, this one is the same. 1 times the width, the length is 1/3 square. So this is 1/3 square. So this one is similar. Length is, this width is 1. The length is here 1/4 square. So area is 1/4 square. So this one is 1/5 square. You can choose 6 with the same idea. You can make a rectangle, find area 1/6 squared, and so on. So next, you have to add these all areas. You can add all areas, this one, and keep going. So keep going, add infinity many rectangles you can add. I'm going to compare with improper integral from 1 to positive infinity 1/x squared dx. So which one is bigger? So this one, the sum of rectangles or improper integral. Which one is bigger? So what do you think? So which one is bigger? Improper integral or the sum of the rectangles? The improper integral is like bigger. So you're right. We have this integral because what is improper integral? Improper integral is area under the curve 1/x squared. So integral from 1 to infinity 1/x squared is you have to include this one and rectangle, this one and rectangle, this one and rectangle. We have more areas, so this is bigger. The next is I want to add 1/1 squared to the both sides. 1/1 squared to the both sides. So we have this one. So next one, how can you calculate? This is summation. Sorry, integral. The improper integral. How can you calculate improper integral? You can calculate like this. 1 to infinity, 1/x squared. You can change it to the limit. The t approaches positive infinity, integral from 1 to t. I can change 1/x squared to the negative exponent form. This one. Next, limit t value approaches positive infinity. So this is antiderivative is 1/the -2 plus 1, x to the -2 plus 1 from 1 to t. This is idea. So and calculate. Keep limit t value approaches positive infinity. You can change this one. The 1 over minus 2 plus 1 is negative 1. The x to the negative 2 plus 1 is x to the minus 1, 1 over x. We have minus 1 over x from 1 to t. You plug t and 1, so we have limit t value approaches infinity, you plug t, negative 1 over t, minus plug 1, minus 1 over 1. So t value approaches infinity. So what happens? Minus 1 over t. So what happens? Minus 1 over t? So what do you think? What's the limit of minus 1 over t as a t value approaches infinity? So what's that? Right. Sorry. You're right. Thanks. The t is going to infinity. The minus 1 over infinity is 0. It's going to 0. The remaining thing is the minus 1 times minus 1 change positive. Answer is positive 1. So this improper integral is positive 1. So what's that? Here. So this summation is exactly same to here. Summation n equals 1 to infinity 1 over n squared. So this one is less than or equal 1 over 1 squared plus another finite number 1, the exactly 2. The 1 over n squared is always positive, so we have between 0 and 2. What is summation n equals 1 to infinity 1 over n squared? So this is just less than 2. We don't know exact number. We know this is finite. So summation is a finite number. What does it mean? Series is convergent. This is like idea. Convergent. It's good. So what's that? So what kind of method do you use for checking summation from n equal to 1 to infinity? 1 over n squared is convergent. We can use improper integral. Step 1, you can replace 1 over n squared by the 1 over x squared. The next, calculate improper integral. Improper integral is equal to 1. What does it mean? Improper integral is convergent. What happens? Corresponding series. The corresponding series is also convergent. We call this is integral test. It's like integral test. Here, like this. The convergent. The next example is the summation n equal to 1 to infinity 1 over the square root of n equals 1 over the square root of 1 plus 1 over square root of 2 plus or something like that. So how can you prove? Similar. F of x is 1 over square root of x. You can change it, the n by x. So next to sketch the graph, we use same idea. The same idea. We can draw graph. This is 1 over x. You choose 1. You plug into this one. So we have 1 over. You plug 1 into x. You're right. Plug 1 into here. 1 over square root of 1. This is right here. 1 over square root of 1. The next is choose to find function value, the same. You plug into curve 1 over square root of 2. You choose 3. This is 1 over square root of 3. You choose 4. 1 over square root of 4. So keep going to this procedure. So next, so we can make a rectangle. So in this case, so we can make a rectangle by using like above the curve. We can make like this one. So like this, you can make this rectangle. So similar, make rectangle like this. Make a rectangle like this. You choose 5, same. Here, so like this. So keep going. So what's like area? The similar. 1 times height is, this height is 1 over root 1. What times 1 over square root of 1 is 1 over square root of 1. So this one is similar. So 1 times the height is 1 over root 2. So keep going. This is same. With this 1 times length is this one, exactly 1 over root 3. So 1 times 1 over root 3 is 1 over square root of 3. Here, 1 over the square root of 4, the same. You can add all rectangles. Compare with improper integral from 1 to infinity, 1 over the square root of x dx. So which one is bigger? The sum of rectangles or improper integral? So which one is bigger? Summation is bigger? Summation of the rectangle is bigger? Yes. Was it like improper integral? Improper integral is the area under the curve, just this area, this area here. The exclude this portion, exclude this one, exclude this one, exclude this one. So rectangle is bigger. We have it. Next, you calculate integral from 1 to infinity, 1 over square root of x dx. How can you calculate? Same idea. You can change the limit. t-value approach is positive infinity, integral from 1 to infinity. So I can change this one to the power form. This is same to what? So 1 over x to the 1 over 2. You can change it to the negative exponent minus 1 over 2 dx. The next to find antiderivative. Limit t-value approaches infinity. So we can use this one. This is 1 over power plus 1 x to the power minus 1 half plus 1 from 1 to t. And calculate. This is limit. The t-value approaches positive infinity here. 1 over minus 1 half plus 1 is 1 over 1 over 2. The reciprocal is 2. X to the minus 1 half plus 1 is x to the positive 1 half, change back to radical x from 1 to t. The next plug. Limit t-value approaches infinity. So exactly plug t first, 2 times the square root of t minus 2 times square root of 1. So next, t-value approaches positive infinity. So what happens? 2 times the square root of t. Going to, yes, infinity. The infinity minus 2 is also, yes, infinity minus 2. What is infinity minus 2? Yep, this is also infinity. like this. We have this one is infinity. So what happens? We have this conclusion. You can change this summation to the summation notation. The summation n equal to 1 to infinity 1 over square root of n. So is greater than or equal to infinity. So what is summation n equal to 1 to infinity 1 over square root of n? What's that? So what is the answer? Answer is, so here, so this value is always you're right. You're right. Yeah, you're right. So it's going here. This one greater than or equal to infinity. This is also infinity. So what does it mean? Divergent. So how can you know this series is convergent or divergent depending on improper integral? Improper integral is infinity. Automatically corresponding series is infinity. This is like idea for checking. So series is convergent or divergent. You don't need to check it. The summation is larger or smaller than the integral. You don't need. This is just only explanation. So what does it mean? This is what the meaning is like one. The improper integral is finite number. You can make smaller rectangle. The improper integral is infinity. Always make larger rectangle. This is like whole idea, but you don't need. Only check improper integral. The improper integral is convergent automatically. So series is convergent. The improper integral is divergent. Series is divergent. The next one. So what kind of series can you apply integral test? The next one. Here, 1 over square root of n, you can change it to the function 1 over square root of x. We have three conditions. First one, here, what happens to this graph? Decreasing. The decreasing. Another one, above x-axis, only positive function. Another one, continuous function. Function f is not continuous. We cannot find the improper integral. So we need the three conditions for using integral test. What's that? Function f is continuous, decreasing, positive. We can use exact integral test. I will now summarize. What's like integral test? Suppose f is this important thing. What's that? I just said before here. Continuous, positive, decreasing. On interval 1 to infinity, the an is f of n. The series is convergent if and only if the improper integral is convergent. In other words, next one, if improper integral is convergent, the corresponding series is convergent. If improper integral is divergent, then corresponding series is also divergent. We call the integral test. This is the idea. So remark, in general, the summation of an is totally different improper integral, is right? The y here, previous one, like this. The improper integral is just area under the curve. Was it like a summation? The summation is add more areas, totally different. So really be careful. So here, the usually different. So like this. The test series for convergent or divergent. So you can check. The f of x equals 1 over x squared plus 1. So this the sequence is series is given. You can replace this m by x. M by x. We have make a function. This function is continuous. Is right? The function is continuous. It's good. Was it like a domain? Domain is always 1 to infinity. You can plug any number greater than or equal to 1 into x, always well-defined continuous. The 1 of x squared plus 1 is always positive. You plug any number greater than or equal to 1 into x, this is always positive. Third one, the denominator is increasing automatically, this whole thing is decreasing. So satisfies 3 conditions. Continuous, positive, decreasing. So we use integral test. The take integral from 1 to infinity, 1 over x squared plus 1. You can change it to the limit and definite integral, limit t value approach infinity, integral from 0 to t, 1 over x squared plus 1 dx. So what is integral 1 over x squared plus 1 dx? Do you know answer? What is integral 1 over x squared plus 1? What do you think? Was it like integral 1 over x squared plus 1? Arctangent is right? The arctangent? Yes, this is definition. The inverse tangent of x. From 1 to t, take limit. Next, plug t and 1. The inverse tangent of t minus inverse tangent of 1. What is inverse tangent of 1? What's inverse tangent of 1? Pi over 4? Yes, is unknown value theta. You can use a definition. So this is 1 equals tangent theta. So what's it like a theta? Theta is pi over 4. So that's it. This is pi over 4. So we have it. The next one, t value approaching infinity. What's that? This inside the t approaches positive infinity. What happens? Inverse tangent. What's that? What happens inverse tangent? Approach pi over 2. So yes, you can just sketch the graph inverse tangent of x. The inverse tangent of x is graphed like this. We have the horizontal asymptotes, the pi over 2. This is negative pi over 2. The graph is increasing graph. Just approach it to horizontal asymptote. The t value, this is like inverse tangent of t. The t value approaches positive infinity. Inverse tangent of t approach to pi over 2. So this is pi over 2. So what's that? Exactly pi over 2 minus pi over 4. Answer is pi over 4. So like this. So like this. What does it mean? The improper integral is convergent. We can use integral test. What's the conclusion? Corresponding series is also convergent, but this is not equal to pi over 4. So we don't know. So we don't know convergent number, just convergent. Just convergent. For what values of p is the series? Summation n equal to 1 to infinity, 1 over n to the power p, convergent. So note, do you remember the test for divergence? Do you know test for divergence? Do you remember? The test for divergence, exactly last lecture. The test for divergence is here. If limit of an as n approaches infinity does not exist or is not equal to 0, then summation from n equal to 1 to infinity an is divergent, always divergent. We call test for divergence. So I want to think about case 1. P is like less than 0. So what's that? I'm going to give one example. The P is like negative 2. Just one example. You can plug a negative 2 into here. What is summation n equal 1 to infinity 1 over n to the power negative 2. You can change it to the summation n equal 1 to infinity n square. You can change it to the positive one. This n squared is like an. You can take limit of an, limit n approach infinity an. You can calculate limit of an. This is a limit n approach infinity n square. What is the answer? What's the limit n square as n approach infinity? Yes, infinity. Answer is infinity. So what does it mean? Limit value does not exist. Does not exist here. Limit value does not exist. What's the conclusion? Summation is always divergent. Divergent by using test for divergence. This is like idea, right? So same. The p is like less than 0, take negative p is positive. So this one, limit of sequence an, change to the n to the minus p, the negative p is positive number. So n is going to infinity. The infinity to the positive number is infinity. By using test for divergence, summation 1 over n to the p is divergent in this case. The next second case is p is 0. So what's it like p is 0? Same. I'm going to take 1 over n to the p. You plug 0 into here. This is limit. N approach infinity, 1 over n to the 0. This is a limit. N approach infinity, n to the 0 is 1. 1 over 1 is 1. What is the limit of 1? What's the limit of 1? Yes, the limit of 1 is, you're right, thanks, the 1. The limit of 1 is 1. So what does it mean? 1 is non-zero. You can use test for divergence. What's the answer? Here, limit an is not equal to 0. The conclusion is summation is divergent. So we have summation n equal to 1 to infinity. 1 over n to the p is divergent. It's like a whole idea, like this. The next one, the p is greater than 0. The third case, how can you check? The series is convergent or divergent here. We can use like previous result. We know integral 1 to infinity, 1 over x to the p dx is convergent if p is greater than 1. The divergent if p is less than 1 equal to 1. We can use this result. Case 3, p is greater than 0. So f of x equals 1 over x to the p is continuous. One example is the p is like positive 2. What's like f of x? F of x is 1 over x squared. The 1 over x squared is, continuous, positive, decreasing. This is always true. Any positive number p. In this case, we can use integral test. What's integral test? Here, improper integral 1 to infinity 1 over x to p is, we calculate this one. This is convergent, the series is convergent. Improper integral divergent, series divergent. We can use this result. So we have two possible answers. This is convergent, so if the p is greater than 1. This is divergent if p is less than or equal to 1. In this case, was it like a third case? P is greater than 0. We have this one. You can use integral test corresponding series. Corresponding series is same result. convergent or divergent. We have same result depending on P. P is greater than 1, convergent. The P is these numbers, divergent. Is right? Divergent. So we can combine other cases. Was it like other cases? Case 1 and 2. Was it case 1 and 2? P is less than or equal to 0. In this case, was it like result? Summation n equal to 1 to infinity. 1 over n to power p is always divergent by using the test for divergence. You can combine all cases. Case 3. P is greater than 1, convergent. P is between 0 and 1, divergent. So P is less than or equal to 1, also divergent. You can combine all cases. We have this result. So we call this is P series. Summation n equal to 1 to infinity, 1 over n to P is convergent if P is greater than 1, divergent if P is less than or equal to 1. So we call P series. I'm going to give one example. Summation n equal 1 to infinity, n to the power negative 1.1 is given. This series is convergent or divergent. What is your answer? What is the answer? Convergent or divergent. The summation from n equal to 1 to infinity, n to negative 1.1. So n to power negative 1.1. Convergent or divergent. What is the answer? What is your answer? Divergent, divergent, convergent. Because this one is, I want to change it to the 1 over n to the p form. What's that? Summation n equal 1 to infinity. 1 over n to the power 1.1. So what's it like a p? The p is 1.1. Is right? P is 1.1. 1.1 is greater than 1. Answer is convergent by using P series. So really be careful. Right? Does it make sense? So like this. Summation n equals 5 to infinity. 1 over n to the 0.9. Convergent or divergent? Is it divergent? Is it right? Yeah, this is divergent. You're right. This is 0.9 is like P. P is less than or equal to 1. This is divergent. One more. What's the index? In this case, 1. You can replace any positive one. It doesn't matter. You can change the 1 into positive number A. This is a positive number A. We have same result. This is 5. It doesn't matter. This is also divergent by using P series. This is like idea. So one more example. To determine whether the series summation from n equal to 3 to infinity, 1 over n times ln of n is convergent or divergent. So similar. You can replace n by x, 1 over x times ln of x. What's the domain? Domain is the starting number here, exactly 3 to infinity. You can check. This is continuous. Is it continuous? You're right. This function is continuous on this domain. F of x is continuous. Is right? The f of x is continuous. Yes. Yep. But because you can plug any number greater than or equal to 3 into x. This is always well defined, continuous. So one more. So you can plug these numbers into x. The x is positive, ln x is positive. What's like ln of x? Ln of x is graphed like this. This is 1. This is ln. The x value is the greater than 3. Corresponding graph is always like above x-axis. This is always positive. So another one. So this is another one. So this is also decreasing. The bottom is like increasing. The fraction is decreasing. We have continuous positive decreasing. We can use integral test. You can define improper integral 3 to infinity 1 over x ln of x. Change to the limit and definite integral limit t value approach infinity integral from 3 to t 1 over x times ln of x dx. You can change it like this. The next, you just only find this integral. How can you find this integral? So which method do you want to use for solving this integral problem? So we learned the 5 methods: the U substitution, integration by parts, the trigonometric substitution, the partial fractions, just the formula. So which method is possible for solving integral from 3 to t 1 over x ln of x dx? So which method do you want to use? How can you find this integral? The U sub. Okay, what is U? What is U? Yes, ln of x. So because what is tu? The tu is ln of x prime dx. So we have the tu is 1 over x dx. Like this. You can replace. This is limit. T value approaches positive infinity. Integral 1 over this one. ln of x is u. Another one. 1 over x dx is du. So we have only du. The next, you have to change it, lower limit, upper limit. You can plug 3 into here. So we have ln of 3. You can plug t into x again, ln of t. Change it like this. So find antiderivative. Limit t value approaches positive infinity. What is integral 1 over u du? What's integral 1 over u du? So integral 1 over u du is, do you know what's integral 1 over u? What's integral 1 over u? Do you know this one? This one? Yes, ln of absolute value of u. This is ln of absolute value of u from ln over 3, ln over t. So like this. The next, plug. T value approaches infinity. So you can plug ln of t into u, ln of absolute value of ln of t minus ln of 3. So like this. The t value approach infinity was like ln of t. ln of t approaches, what's that? T value approach infinity, what happens ln of t? You're right. Here, you can sketch the graph ln of x. This is ln of t. The t value approach infinity, ln function is going to positive infinity. This is going to infinity. The ln of infinity is also infinity. This is like a finite number. Infinity minus finite number is infinity. So what does it mean? Improper integral is divergent. So we can use integral test. The conclusion is like this. The corresponding series, summation from n equal to 3 to infinity, 1 over n times ln of n, diverges. This is whole idea for solving this problem. Okay. This is all for today's lecture. So if you have any question, could you write your question on the chatting board? So if you don't have any question, you can leave live session. So thank you for attending my live session. I really appreciate. So do you have any question? No, it's good. You're welcome. So you're welcome. Have a nice day. Have a nice day. Thanks. Okay, bye.